welcome everyone to the pavementdesigner.org background and demonstration webinar. The webinar will last for about an hour, and then at the end we'll have 15 minutes of question and answer time. Everybody's muted at this time and will remain muted throughout the webinar. If you have questions, then just go to your questions pane and enter your question in, send it to me, and then at the end of the webinar, I'll try to address as many of the questions as I can. If there's something during the webinar that you'd like to go back and review, there's a couple of ways you can do that. One, we'll post a recording of this webinar on the NRMCA YouTube channel. That should be posted within a day or two after the conclusion of the webinar today. And then we'll also post the presentation portion, the PDF slides, on our paveahead.com website. So there's two ways in which you can get some information about the webinar. Okay, with it being a minute past, we'll go ahead and get started so that we've got plenty of time to get through the webinar and on to the demonstration. My name is Brian Killingsworth. I'm the Executive Vice President and Division Head for the local paving division at the National Ready Mix Concrete Association. My job focuses primarily on parking lot and street promotion and technical assistance. Been with NRMCA a little over 6 years. And prior to joining NRMCA, I was in the private industry as a paving consultant. Done a lot of different pavement design, materials construction, and forensics on both concrete and asphalt and granular pavements. And I'm a registered professional engineer in the state of Texas, and went to Texas A&M University, where I got my bachelor's and master's degree in civil engineering. One of the things I want to point out is that across the nation, we have support for you. We have NRMCA personnel in 6 different regions across the U.S. To get their contact information on anything related to the local paving arena or anything that we talk about in the webinar today, just go to the paveahead.com website, and under the Meet the Experts page, you can find contact information for the person in your region. Today's webinar will qualify for PDH or Professional Development Hour certification. And if you'd like a certificate, just send an email request to me at bkillingsworth@nrmca.org. Send that from the email that you registered with. And then after we confirm your registration and that you participated in the webinar, then we'll send you back a certificate. Should be back to you within a couple of weeks. If you have multiple attendees at one site, then just send me a list of the names and email addresses for all the attendees, but make sure that in that email you indicate a statement that confirms that all attendees completed the webinar. So what we're going to talk about today is the need and relevance for the pavementdesigner.org website. And then talk a little bit about the development and technical background with the different paving design methodologies that are in the website. Give you some references that you can use if you need a deeper dive into the design. And then also each of those references do have information contained in them about construction. We know that we can design a pavement well, but if we don't construct it well, then the design is really kind of pointless. So each of the references that I talk about will have some construction advice as well. Then we'll go to the actual live pavementdesigner.org website, and we'll do some demonstrations doing parking lot, street and road, and then the intermodal design. And then again, at the end, we'll do some question and answer session through the GoToWebinar questions pane. Now, the pavementdesigner.org website was developed through a consortium of associations. It was the American Concrete Pavement Association, National Ready Mix Concrete Association and our associated research and education foundation, the Portland Cement Association, and then also some contributions from the RCC Pavement Council. So the website addresses the needs for all of the members of these types of associations. So the question would be, what was the reason behind developing the website? Well, one is just really to address the demand out there for a good, robust design system. If you're doing highway paving, then the AASHTO Pavement ME software is really most appropriate. It's appropriate for higher traffic type of situations. But if you're not doing those highway type designs, if it's a non-DOT agency or a consultant, then we want to provide a design tool that was affordable, easy to understand in terms of the input that you needed to put into the program, and then also what was provided as output. It's applicable to traffic levels that are low to moderate. Those are the parking lots, the streets, roads, county roads, things like that. But also utilizes widely available and cost-effective materials characterization. So when we're trying to characterize concrete materials or soils, those types of things, the testing requirements are not what we consider difficult to do or difficult to obtain the services for. Designers, they really value that quick access to the design tools that gives them those robust answers. And so that's what we're trying to accomplish. In other venues, students, professors, college level type of things, the website can also provide solutions for the college professors to be able to educate from, and for students to be able to understand how to do concrete paving design. Another reason why we wanted to make sure that there was an easily accessible and robust tool out there is because there are some other tools out there sponsored by other industries. And what we have found is those tools have what we consider very, very conservative designs for rigid pavements. We've looked into this extensively and did some reporting on it. And you can see here, just if you look at the blue line there, for example, we ran several case studies using the Pave Express program put out by the asphalt industry, developed that does concrete designs as well as asphalt. And when you look at just running against the typical AASHTO 93 design versus what you get out of Pave Express, you can see that there's a very significant difference in terms of the overall thickness calculated. The items coming out of Pave Express were considerably thicker than just what you would get from either the AASHTO 93 or the AASHTO 98. So we wanted to make sure that there was a robust tool, an accurate tool that was available to users in the marketplace. Another reason why we wanted to put the website together was because if you were to go out and Google, find programs for designing concrete pavements, you would get a lot of different software identified. Whether you're doing structural design for jointed plain concrete pavements or overlays or roller compacted or for parking lots, there was a wide array of tools that were available to you, and it could be confusing at times, trying to figure out what the best choice is in terms of the software to implement. And so that really contributed to what we would consider a negative perception that cement-based paving solutions are difficult to design. And so we wanted to make it as easy as possible for those users or for those designers that want to do concrete pavement design. And putting all of that into a single website was really the motivation. So through our partnership with ACPA and PCA and the RCC Council, we've developed this website for, again, streets and roads, parking lots, and then also for intermodal or industrial facilities. And the tools will help you design jointed plain concrete pavements. Those are concrete without reinforcing steel, although they can include steel dowels at the joints. For continuous reinforced concrete pavement, concrete overlays, And then also composite pavements. These are typical pavements, or these are types of pavements that have treated base materials. Then also for roller compacted concrete, cement modified soil, cement treated base, and cement are the full depth reclamation with cement. Those are what we would consider the composite pavements. So the idea was to take all of these various software programs, put them into a website that would be usable for multiple platforms, whether you're working off of a PC, a laptop, or even a tablet. And so we wanted to make it as easy as possible for users to develop appropriate pavement thicknesses for concrete paving. Now this shows what we would consider the map for the website. And what it shows across the top there, if you're doing parking lot design, street design, or intermodal design, it shows the various options that are available to you and the design methods that are available as well. So you can see under a street, for example, if we're going to do a concrete street, we have options of jointed plain concrete pavement, that's the JPCP, roller compacted, the RCC, or the continuously reinforced concrete pavement, the CRCP. And then it shows the different methodologies down at the bottom for each of those designs. Now, concrete basically considers, when we're doing pavement thickness design, considers two different types of failure modes. One would be transverse cracks at mid-slab, and also faulting, which is typically a result of under-slab erosion. The analyses that we'll be performing today during the demonstration, they're very robust, like I've mentioned before, and it roots back to the 1960s PCA method for fatigue and faulting design, with some enhancements over the years. That design really is tailored for this lower volume, low to moderate traffic volume parking lots and streets. When we're looking at determining fatigue properties or fatigue failure mode, we use what's called limiting the stress ratio. So what we're looking at is a calculated stress based on the loads on the pavement from the axles, divided by the concrete strength, and that's our stress ratio. And we're trying to minimize that stress ratio by providing sufficient thickness to mitigate those mid-slab fatigue cracks that can occur. Now, when we consider faulting as a distress failure mode, if we utilize dowels across our transverse joints, then faulting is mitigated. That's the assumption that we're making, and the pavement would fail in cracking. Now, the analyses that we conduct in the pavementdesigner.org are based on some data that was developed in the 1980s from Wisconsin, Minnesota, North Dakota, Georgia, and California. It's similar to the cracking models in that the pavement is made thicker until the faulting model predicts that the pavement will not fail by faulting during the design life. This is one area in which we want to improve the modeling. So future versions of Pavement Designer will include a revised erosion and faulting model. One of the things that is a little bit different than what you'd see from, say, the AASHTO 1993 pavement design methodology is we utilize traffic spectrums and axle counts to determine what those stress ratios are. So we have a total trucks in the design lane that's calculated from the total trucks per day. That's a two-way traffic number that you input. The traffic growth rate in terms of a growth percentage per year, the design life, the directional distribution, and the design lane distribution. So we get a total number of trucks over the design life with the axle load spectra for the street type that you are, or the parking lot that you are designing. We'll show you that a little bit further when we get into the actual design. It's important to understand kind of the basis of the pavementdesigner.org website and where you can go for further reference when you're actually doing the design. We'll go through the demonstration today, and you can see how simple the input and output is from the program. But if you need to do a deeper dive, then you need to be able to refer to some reference material. And so I've provided here this table that shows the various reference material that we recommend for the type of facility that you are designing, whether it's a parking lot, a street, or an intermodal design. So this is just a summary table, and I'll just take you very quickly through each one of those, and then also some of the collateral or support help that you can get from NRMCA and our other associations. Now, when we're constructing or when we're doing designs for new parking lots, reference material that's good to refer to is the ACI 330-08 Design Guidance for Conventional Concrete Parking Lots. This is developed by the American Concrete Institute, and you can obtain it through the concrete.org website. This reference has great information both on the design. It also has some design tables, so if you just need to do a very quick design, you know your traffic and soil conditions, you can enter into a table and determine what thickness of concrete you need. If you need to go a little bit further, then you can jump into the pavementdesigner.org website and actually conduct a design there. When we're doing parking lots, the design criteria that we're looking at is minimizing mid-slab cracking. Typically in lower volume parking lots, faulting is not an issue, and we can mitigate potential issues with erosion just by doing subgrade stabilization or putting a non-erodible base underneath our parking lot. So faulting is not considered as a design criteria in parking lots in pavementdesigner.org. NRMCA has a lot of really good information on how to design parking lots. We have a ACI 330 quick reference guide, a frequently asked questions guide. We have collateral that talks about the lighting benefits. And then we offer a design assistance program where we can help you kind of design that parking lot, making sure that you're using all of the right inputs and specifying all the appropriate materials and construction properties in your specification. You can go to the paveahead.com website to get that design assistance. Just simply fill in your information and it'll send us an email and we'll get back to you to help you design your project. Now, if we're doing new construction for a street and we're doing a jointed plain concrete pavement, then the ACI 325.12R guide is what we recommend for reference. Again, you can get that on the concrete.org website. When we're designing streets, in terms of new construction for jointed plain concrete, our design criteria is to minimize faulting and minimizing mid-slab cracking. So those are the two failure modes that are considered, and I'll show you how you can see your fatigue life and your erosion life and as it develops over its design life when we do the demonstration of the program. Again, NRMCA has some good technical support for designing concrete streets. We have a rigid pavement technical assistance resource for local jurisdictions. Again, you can get that at the paveahead.com under the resources page. Has various tabs within that document that help in terms of how do I design, how do I classify traffic, when do I use a sub base or not, when do I use dowels or not. So it has a lot of really, really good information for those that are kind of just getting started with designing and constructing concrete pavements. Now, if we're going to design a continuously reinforced concrete pavement, for new construction in the street, then we recommend utilizing the FHWA's report for continuous reinforced concrete pavement. It's design guidelines for construction and maintenance and rehabilitation. You can also go to the crcpavement.org website. Now, I will say, when you design using pavementdesigner.org, doing CRC pavement, the website will pop up a little box that says, hey, we really recommend using AASHTO Ware's pavement in ME, but if you want to go ahead and design a CRC pavement with pavementdesigner.org, you can do that, but we're going to be utilizing in that software the AASHTO 93 design guidance. What does that utilize? Well, what you do is you get your steel percentage based upon the steel reinforcement by crack spacing, maximum crack width, and the maximum steel stress. So again, we really typically recommend that you use the AASHTO Pavement ME for CRC design, but you can use the pavementdesigner.org to get a quick and dirty check. Also, if you're doing a street new construction and want to use roller compacted concrete, you can choose that. The reference that I would recommend for that is the National Concrete Pavement Technology Center's Guide for Roller Compacted Concrete. And when we are designing RCC for a new street, the design criteria is faulting and mid-slab cracking. And then lastly, for streets, when we're doing new construction using a composite pavement, typically that is when we are doing full depth reclamation with cement and then putting a thin concrete surface on top. We can also design using a cement modified soil or a cement treated base. The reference for full depth reclamation comes from the National Concrete Pavement Technology Center in conjunction with the Portland Cement Association. So that's what we recommend. That report is what we recommend for FDR. If you're using cement modified soil or cement treated base, reference material from PCA can also be utilized to help you with that design methodology. When we're looking at jointed plain concrete in the new composite paving design, what we're using as a failure criteria is faulting and mid-slab cracking. We do have in the pavementdesigner.org options for design of a hot mix asphalt surface or a chip seal surface on top of treated base materials. So we do have that option in pavementdesigner.org. Probably won't have time to demo that option today, but in future webinars we'll do that. Now, when we're doing concrete overlays, particularly in parking lots, the reference that we suggest is the National Concrete Pavement Technology Center's Guide to Concrete Overlays of Asphalt Parking Lots, or what we call the Green Book. This is a great book with design tables in it as well. So if you just need to do a very quick design, you can enter into tables. If you need a little bit more robust design, then you can utilize the pavementdesigner.org. And this is for bonded concrete overlays on asphalt. Typically, the design criteria there that's used is mid-slab cracking. I'll show you briefly in the demonstration that there is another website that we link to when we're doing bonded concrete on asphalt. And I'll show you that during the demonstration. If you're doing bonded and unbonded concrete overlays, either on concrete or asphalt for a street, there's another guide by the CP Tech Center. It's what we call the Blue Book, 3rd edition. Utilize that reference. There's a little bit of repeated information between the Green Book and the Blue Book, but they really have two separate purposes. So if you're going to be doing an overlay for a street, use the Blue Book. More information for streets on bonded overlays of asphalt. The Illinois Center for Transportation has a great reference there. It was published in 2008, but still has very good reference and gets into a little bit of the design theory as well as the University of Pittsburgh, the BCOAME program that we transfer you to in the pavementdesigner.org also has a theory guide as for reference. So that's a good one. So when we're doing bonded concrete on asphalt for streets, there's 2 or 3 good references for you there. When we're doing bonded concrete on asphalt for streets, typically, again, the design criteria that we're designing for is minimizing mid-slab cracks. Now, in intermodal, new construction for jointed plain concrete, the reference that we suggest is the ACI 330.2R. This is different than the ACI 30-08 for standard parking lots. This is for industrial and trucking facilities. A lot of really good reference information in there for these more heavy-duty designs. And here, what we look at is focusing on minimizing cracking through that stress ratio. We do that in the other designs, but it's done kind of behind the scenes. On the intermodal, it shows you very plainly what the stresses are that are calculated for various configured heavy non-over-the-road type vehicles, those being gantry cranes and forklifts and things of that nature. And I'll do a quick demonstration of that as well. So one thing that we have not talked about is pervious concrete. Pavementdesigner.org was not really developed for doing pervious concrete design, although it can do the structural design. What pervious concrete is, it's a no fines concrete that allows water to flow through it and then flow through a permeable base material and into the subgrade and down to the water table. There's a couple of different ways that you design pervious concrete. You do have to do a structural design to make sure that it can handle the traffic conditions, and you can utilize pavementdesigner.org for that. But that's really for those people that understand the material properties of pervious concrete. So if you have not done that, then I would suggest you seek out some design assistance through NRMCA or some of our partner associations. And then we also have to do a hydrologic design for the environmental conditions so that we understand whether or not the pavement and the base can handle the water that is being discharged onto the pavement. You can utilize ACPA's Pervious Pave to do both a structural design and a hydrologic design. There's other types of design methodologies out there for pervious pavement. If you need help or assistance with that, you can go through the ACI 522 R-10 report, or you can just contact, again, one of the partner associations, and we'll be glad to help you. So in summary, the pavementdesigner.org is the primary audience, really, are those city, county, consultant engineers who are designing concrete pavements. Again, not really for highway type design. But a secondary audience would be professors and students, and the goal, and I think the objective, and it was met, was to really unify these design methods that are out there that provides industry promoters and our primary audience, those designers, really a single source to direct target audiences to get robust and also consistent answers, and we think that's really important. Again, we made it as a web-based platform so that it appeals to those folks that have been using the software, the various different concrete pavement softwares in the past, and then also for future generations of design engineers. And we really had great broad industry support from all the different associations and from many of the member companies in those associations as well. And most importantly, the website is free. It's easily accessible across all different types of platforms. And that was what was really important to us, to make sure that it was out there for people to be able to utilize and give what we considered very robust and appropriate designs for their conditions. Now, again, just refer you back if you need professional development hours for today's webinar. Send me that request. If you have multiple people at a site, send their names and email addresses, and I'll make sure that we get PDF certificates to everybody. Okay, so now we're going to try it out. Again, a reminder, if you have questions, just type those into the questions pane and we'll deal with those at the end of the demonstration. And we'll also have the webinar recording posted to the YouTube channel here in a couple of days, and then we'll post the PDF of the presentation that I just gave on the PaveAhead website. All right, so I'm going to move a couple of things around a little bit, and we will show the live website. All right, and there's the live website. So when you go to pavementdesigner.org, this is the welcome screen that you'll see. Along the left, you'll see some tiles, and that shows various things that are associated with the website. The first that I want to show is our resources page. I showed you a lot of different resources in terms of reference materials and things like that. There's also a lot of good information and resources that we have online. If you go to that resources page, it'll take you to another website that shows various tiles. There's a Pavement Designer intro video. There's that map that I showed earlier in the presentation, little video tutorial. And then also you can get to the concrete wiki page. So there's a lot of different WikiPave pages out there that have been developed by ACPA. So these are the first 4 tiles of information. If you want to load more, you just simply scroll down to that button, hit that button that says load more. And additional pages will, tiles will come up. There's ACPA's app laboratory there, or library there. So there's a lot of different tiles that pop up under this resources page. Very easy to get to some of those reference materials, like on the right there, you see the blue version of the Concrete Overlays book. You click on that, it'll take you straight to the CP Tech Center website to download that book. So a lot of good resources online that you can refer to, and you can get to those through the pavementdesigner.org website. So we're going to go back to the website. And here, when you get to the welcome screen, you'll see this button here that says Start Designing. You can do designs as a guest. You don't have the option to save those designs. So if you want to save those designs, what you'll want to do is register for an account. You do that there under the Register Now. Or if you have an account already, then you can log in. When you log in, it allows you to save your design so that you can go back into the future and take a look at those designs. So I'm going to log in. Typically, it's just an email as your registration. Put in your password, and you sign in. And what we'll show you down at the bottom there, it'll tell you that your login was successful or not. If it's not, then you can recover your password. So now that we've done that, we can do one of 2 things. We can start a new design, or if you want to go back to a design, you would click over here on the left to My Designs. And what it shows is all the designs that you have saved under your project folder. You can see here I have 3 different designs saved. You can go into those and edit them. You can delete them. You can print them. There's different things that you can do. So under this dashboard, it shows all of your designs, and you can change those folders if you wish. You can put in a new folder so that you can separate these designs out by client or however you would like to do that. The other option is just simply to start a new design. So if we press on New Design, then we can create a new design. We can put in all of the appropriate information. And what this does is it saves this information for our reporting at the end. So you have a header block that is filled in your report based on what you input here. So once we have all of our data input, then we start our project. What that will do is bring you up to this opening screen where you select the project type, where you have an option of a parking lot, a street, or an intermodal facility. Right now, what we'll do is we'll go through the parking module, and we'll show you, again, this is based on the ACI 330 methodology. And it's typically for parking lots that has cars, trucks, buses, conventional axles. If you're going to be doing a parking facility that has what we consider non-over-the-road or non-conventional axles, then you would use the intermodal. So we're going to select our parking lot module. And this is broken down into three different inputs, or two different input screens and one summary screen. The project level, the pavement structure, and then the actual calculated concrete thicknesses. So here, first thing we do is we start out with our traffic type. One of the things I want to point out is in the upper right, you see a little button that says help. If you go over to that button, you can see that you can toggle on and off help screens. Right now it's off, but what I'll do is I'll toggle it on. And then as you move over to these input screens, a help screen will pop up that shows under the traffic spectrum, for example, it shows you a little bit about those, what that input is. And then if you want more information, and you can press that more information button, and what that'll do is it'll take you to a WikiPave page that explains that input a little more thoroughly. What we're going to do for our parking lot is utilize the traffic spectrums that are shown in the ACI 330. Traffic spectrum A is for a parking lot that's primarily for cars, so it'd be the front entrance of your store where cars are parking. Spectrums B, C, D, and E have various levels of trucks and higher levels of trucks in those traffic spectrums. So what we're going to design is just for traffic spectrum A. If you were to change the traffic spectrum from A to B, what you'd see is a change in axle spectrums. You can see here we have a single, tandem, and axle spectrums, and it shows for the ACI 330 traffic spectrum that most of the axles are single axles of low weight. So 4 kips or 4,000 pounds down the bottom left of the table, and we have approximately 1,700 of those axles per 1,000 trucks. And then we see the tandem axles in terms of the axle distribution over here on the right. Again, if we were to change that to a spectrum B, you would see a little bit more of the heavier axles show up in that traffic spectrum. So we're going to design this parking lot for 20 years. And we'll say that we're going to have just 1 truck per day that actually traverses this pavement that's in the front of your facility. We're going to use a design reliability of 75%. This design reliability really is kind of a safety factor for the pavement design. And pop up here and it shows us what appropriate safety factors are or reliability factors are for the different types of facilities that I have. So parking lots, local roads, those reliability levels range anywhere from 50 to 80%. And as you move up into the principal arterials, then the reliability level, or that factor of safety, also increases. So this screen tells you a little bit about that reliability factor and what it means. We'll say that at the end of the design life, the end of the 20 years, that it's okay to have about 20% of our slabs that have cracks in them. Okay, so now that we've input all of that information, then we move on to characterizing our pavement structure. Two things that you need to do there is to specify what the supporting structure or soil structure is. We have up here at the top the different types of soils: fine grained soils, sandy soils with moderate amounts of silt or clay, or sandy soils, sandy gravelly soils that have very little of those plastic clay or plastic fines in it. We're going to select a fine-grained soil, a clay-type soil, and what that does is it automatically inputs what the CBR value is for that soil, which is a 3. We could override that if we wanted and put a 4 in there, and when we do that, it will then change what that soil type is. So we're going to go back to a 3. The second thing that we need to do is to tell the program what our concrete strength is going to be. And we have options of the 28-day flexural strength, or the 28-day compressive strength, modulus elasticity, or the split tensile strength. Typically, we'll specify either the flexural strength or the compressive strength. Here, what we'll do is specify a 28-day flexural strength of 550 psi. And then the last thing we need to do is tell the program how many layers of material below my concrete am I going to have. In this scenario right here, what you see is that we are putting the concrete directly on the subgrade, so we have no sub-base layers. We could add a sub-base layer in there if we wanted to. We won't do that in this particular part of the demonstration. We'll do that when we look at our streets. You can override that K value right here, so if you're not happy with that K value, you can check that override button and input your own K value. So now that we're satisfied with our soil information, with our concrete information, and the number of paving layers we have, we simply go to Design Summary, and it tells us for this particular situation that the thickness required is 4.5 inches of concrete on top of that prepared subgrade, with a joint spacing, maximum joint spacing of 9 feet. We have over here, we have different sensitivity plots that we can look at. So if we wanted to change the flexural strength, the K value, the design life, we can look at those sensitivity plots. So for example, if we wanted to look at how sensitive our design is to the concrete strength, what we specified was a 550. That shows us that we needed 4.5 inches of concrete for that 550. If we were actually to change that, let's say, to a 500 psi flexural strength, what would that do to our design thickness? And it shows there that it would increase to 4.75 inches. So we can look at various sensitivity plots. Here's one for design life. And you can see that once you get past about 20 years, the design is fairly insensitive to the design life. Now, what we can do is at this point, we can generate a report. And I'll show you that when we get to the streets and roads section. Okay, so we can save this design if we want. We'll just call it the demo parking. That's what we input when we did our new design. We'll save that. It tells us up here on the right that design was successfully saved. And if we went back to our My Designs, we would see that demo parking show up under the My Design. Okay, let's go back to our home screen. And we will start another design. This time, we'll start a concrete street design. And when it comes here, if we're going to do a street, then we have the option of doing a concrete overlay, just a typical concrete street, or a new composite pavement. What we'll design here will be a concrete street, and we can do either a jointed plane, an RCC, or continuously reinforced. So again, this screen should look somewhat familiar. It has a few more inputs than the parking lot screen did because we wanted to simplify the parking lot as much as possible. But here you have to input information about your traffic, some of those global inputs like our reliability, and then we'll move on to the pavement structure once we do that. Now, under the select spectrum, now what we have is residential, collector, minor arterial, or major arterial. If we were to change one of those, you would see our traffic summary details on the right-hand side change. So what we're going to go to here is a collector street, and you should see some numbers change on the right-hand side under the traffic summary details. So now what we have is our axle distribution per 1,000 trucks for our single and tandem axles for a collector street. Again, we're going to design it for 20 years. Now, there's a couple of different ways you could go here. You can just input your trucks per day, traffic growth, directional distribution, and so on. Or if, for example, you had an asphalt design in front of you, what you could do is estimate what the traffic numbers are for that design, and then utilize that in your concrete design so you can get an equivalent design. I won't go through that, but if you have that opportunity in the future, you can determine that total number of trucks from your asphalt design for your concrete design. What we're going to do is we're just going to put in our trucks per day. Again, this is a two-way traffic number, so 300 trucks per day. The traffic growth rate of 0.5% per year. Directional distribution 50%. So what does this mean? Turn on the help screen there. So what this means, this is our directional split of traffic. So if you have an even split of traffic in both directions, then you would enter a 50%. If you didn't have an even split, you might split it 60-40. But typically in terms of directional distribution, that's 50%. Our design lane distribution, so this indicates that if you have two or more lanes going in one direction, then we might put say 80 or 90% of our design lane traffic in the outside lane. For example, if we have a 2-lane or a 4-lane highway or a 4-lane street, 2 lanes in each direction, our design lane, we might put, let's say, 80% of our traffic in that outside design lane. Once we input that information there, then it shows us our average trucks per day in the design lane over the design life. So we have 126 trucks on average per day. And we have a total trucks in the design lane of about almost 1 million. We input our reliability value. We'll put 85%. We only want to see 15% of our slabs cracked at the end of the design life. Once we put all of that information in, we now have the option of choosing what is going to be our surface material. Are we going to use jointed plain concrete pavement, roller compacted, or continuously reinforced? For this example, we'll go to the jointed plain concrete pavement. And again, now we need to input our material characteristics for our subgrade, for our concrete, and then also choose whether or not we're going to have any subbase layers. So here we have the option of putting in our resilient modulus value for our subgrade, or we can choose a California bearing ratio, the CBR value, or an R value. We'll keep as our resilient modulus value, and we're going to put in a value of 4,500 psi. Here, what we'll do is put in our 28-day compressive strength instead of our flexural strength. We'll say that we'll specify a compressive strength of 4,000 psi. It will calculate the flexural strength associated with that. That's a flexural strength of about 580 psi. If we don't like that number, we can come here and say, well, our compressive strength really is, say, 4,200 psi, and you can see how it would change the calculated flexural strength. Now we're a little closer to 600. You can either put macro fibers in the concrete, or it can have no macro fibers. We'll say no, the way it's defaulted here. It's highlighted no. And then you have to choose whether or not you're going to have edge support, either an extended lane or a tied curb and gutter or a tied shoulder. Here we're going to say yes, we'll have edge support, and we'll assume that that's going to be a tied curb and gutter. We can put up to 3 different subbase layers. For now, we'll just choose one subbase layer. We'll choose to put a granular base material. Find that down at the bottom of that box. So we'll choose this granular base material. It puts in a default value of 25,000 for the resilient modulus of that base material. If you don't like that, you can change it. And then you have to input the thickness that you're going to put down. We're just going to put 4 inches of granular base material underneath our concrete. What that does is it calculates for you the composite K value of the subgrade value and the 4 inches of granular base material. Again, if you don't like that composite K value calculated, you can override that by clicking on that little box right there, the blue box. Okay, we're not going to override it. We're just going to leave it the way it is. And we'll do a design summary. And now here, what it tells us is for either doweled or undoweled paving, what your thickness is. Because the traffic is an axle distribution for a collector street, so it does not have a lot of heavy axles, and there was not a lot of trucks, we don't normally see a failure in faulting. It's going to be a failure in our cracking. If we want to look and see which axles were doing the most damage, we can click over here under Analysis and Guidance. We can click under Cracking, and it shows us the table here. So we see on the left-hand side, we see our axle loads, number of axles per 1,000 trucks, for our single axles, our tandem axles, and then our tridem axles. And if you look on the far right-hand side, it shows that our 24 KIP single axles consumed about 61% of our fatigue, and the 22,000-pound single axles consumed about 21% of our fatigue. So those are the 2 axles that are doing the most damage to our pavement. But what we see is that there's very few of those axles. There's only about 1.6 and 2.6 of those axles per 1,000 trucks, but they do the most damage. We can also look at our erosion table, and it shows you, again, those same axle distributions and the contribution to the erosion consumed. And you can see up in the top right, it shows here that only about 4.5% of our erosion life, if you will, was used. So we can see that without the real heavy axle loadings, that erosion underneath our concrete was not really a problem. If you do want to put in dowels, you just simply look over here at this load transfer screen here, and it will give you some recommendations on when dowels are appropriate and how what the diameter of those dowels need to be, and it will show you where you can get more information about doweling. Now, if we want to look at these sensitivity plots, again, we can look at our flexural strength, for example. We had a flexural strength of about 600, so our recommended design thickness is 5.75 inches. I will make a note here that in the past, we've typically only done recommended designs to the 1/2 inch. So if it was 5.6 inches, we would round up to a recommended design of 6 inches. Because of the new paving technology that's out there, and you can get to some fairly significant or fairly sensitive thicknesses, we decided to round up to the nearest 1/4 inch. So that's what it shows on the screen, and also on your report. So if you do want to generate a report, you come down here to the right-hand side, you input the information. Once you've done that, you can download and view the report. So we'll download a PDF and then also show you the report. So on that report, what we have is the summary block up at the very top. That's this information at the top. A design summary that tells us what the recommended design thicknesses are, what the maximum joint spacing needs to be. Shows you a graphic of essentially what we saw in the program in terms of the subbase and what the subbase thickness and properties are. And then down at the bottom, it will show you the design methodology that was utilized to produce those results. So it's the PCA design methodology that was implemented in StreetPave. So you can get that report there. All right, now just very quickly, want to run through an overlay. All right, well, let's go back here. So we'll start and we'll do street design. And what we want to choose now is an overlay. Run through this fairly quickly since we've already done it a couple of times. Input all of my information. Okay, so once we've input all of our information about our traffic and our reliability, we now come to a screen where we choose the type of overlay we want to do, a bonded concrete or an unbonded concrete or an unbonded asphalt or a bonded asphalt. If we choose bonded asphalt, what it's going to do is take you out to the BCOA ME website so that you do your design there and you can generate your design and report from the BCOA ME website. We did not want to replicate that website within pavementdesigner.org. It was already a great website that gives you very good information and data. So we didn't want to repeat that in our website. So it just takes you out to that website. We won't go there right now, but if you have the opportunity, you can check that. If we want to do an unbonded concrete overlay, it takes you to this screen here, and it shows you all the different inputs. So there's all different types of inputs here where we look at unrepaired, deteriorated joints, the joint adjustment factor. Again, if you want help for those types of things, just simply go over to your help screen, and it should pop up a help box that should pop up a help box that tells you what that input is. All right, so the very last one I want to show you is the intermodal. So we come back to our main screen, hit the intermodal. Now the intermodal, what it has is some predefined project vehicles, forklifts, straddle carriers, container trucks, those types of things. You can select one or multiple vehicles that you want to design for, or as you can see up in the upper right here, you can put your own customized vehicle in. So you could add your vehicle, input the number of wheels, where they're spaced, weight, contact pressure, contact area, that type of thing. So you can add a custom vehicle there. We're not going to do that. We're just simply going to look at, say, a couple of different vehicles, maybe a forklift and a container handler. They have different wheels that you're designing for, or a number of wheels you're designing for. So now we'll go to our pavement structure. Again, we put in the appropriate information, what our flexural strength is. We'll have one subbase layer. It'll be a, let's say a lean concrete base in there of 12 inches. It will determine a K value for you, a composite K value based on your subgrade stiffness and the stiffness of your base material. And then we run that design, and what it's telling us is that container handler is the primary vehicle that you want to design for, to about 15 3/4 inches is what we want to design for. That's reducing our stress ratio to about 0.5. So we'd use a 13-foot joint spacing there. You can, again, generate reports and so on from there. Okay, that concludes the demonstration portion. I will go to the question and answer box now, and we will try to answer some questions. So the first question that's asked is, can I touch on a little bit on the geotechnical part of the investigation and design? That's a great question. Characterizing the subgrade is one of the most important things that we can do in our pavement design. Generally, when we're doing streets and roads and parking lots, just asking your geotechnical engineer to do a few borings around the pavement site and running the California bearing ratio for the different materials that you encounter is sufficient to characterize the subgrade. Other things that you want to know are if you have expansive soils and if you have a shallow water table. Things like that can affect the pavement over time. So it's important to understand that. And we utilize that data, that information, to tell us whether or not subbases are needed, whether or not we might want to go ahead and dowel a pavement. So we utilize geotechnical information to do that. I highly, highly, highly recommend that you get a geotechnical investigation for each of the projects that you're going to do, whether it's a street or a parking lot. I think that's important. So next question, why are there two different areas for changing the subgrade strength in the parking lot design? So if we go back to the parking lot, we put that information in. So we can input that calculated or that soil type either here, so we can select it right here and it calculates the resilient modulus value, and then it also calculates the K value for you right here. It's the K value which is used for design, but many times we do not calculate or we do not run a test to generate that K value. So that's why we input the subgrade value and then it calculates these values for you right here. The resilient modulus subgrade right here is just the value that many pavement designers are familiar with. And so we utilize that as just information, but when we actually run the design, the K value is used. Next question is, how does the trucks per day relate to the traffic summary detail list? Okay, so what we're saying is that there's going to be a certain number of trucks per day that go over our pavements. Now, it's not just going to be a single type of panel truck or an 18-wheeler truck or something like that, okay? What we're saying is we're going to have a certain amount of heavy vehicles, and if you measure those axle loads of those heavy vehicles, then you're going to have that distribution that we showed that's tied to the street type. So whether it's an arterial a collector or a residential street, or that traffic spectrum of A, B, C, D, or E for the parking lots. You can go into the help screen, and that will give you a little bit more information about that relationship between the number of trucks per day and the total number of axles that we have and the weight of axles that we have. Good question here. Is there an option to switch to metric units? In process. That was one of the things that we wanted to include as part of the paymentdesigner.org. We just couldn't quite get it implemented before our date that we wanted to get the website live. So it's in process right now. I don't know when it's going to be available, but I would say not into the too distant future will that be available to you. Next question, how do you assure that the overlay will be unbonded when you want an unbonded overlay? It's a good question. There's a couple of different ways you can do that. There's fabrics and things that you can do that you can place between the concrete and the underlying material. It's one of those things that you may have in a region or in a state. You may have some practices that have worked well in that environmental situation or the materials situation. So what I would say is you can utilize something in between, again, filter fabric or some other sort of material to make sure that you have a bond breaker in between your new concrete and whatever the layer is below it. A question here, why then the modulus of elasticity change when you change the concrete strength? That's a good thing to point out there. We chose not to do that because there's different factors that you can utilize, and so we just wanted to make that an input that the user could change if they want. One thing I will say is that concrete design is not real sensitive to the modulus of elasticity. It can, particularly when it gets very stiff. You can have curling and warping and things like that. But we typically can take that into account with the flexural strength. But we wanted to kind of separate those two so that the user could input their own modulus of elasticity value. Question, can you address CBR versus the dynamic cone penetrometer for strength? So what the question is asking is, can you get the CBR value from a field test versus a laboratory test? And the answer to that is yes, you can. If you want to go take what's called a dynamic cone penetrometer out to your site, you can utilize that field test to get you many more points of what the subgrade strength is. So you can get an idea of the variation of strength that you have by utilizing a field test instead of just taking a couple of soil samples back to the laboratory and running, one or two CBR tests in the laboratory. There's pros and cons for doing laboratory versus field testing, and whether or not there's a good correlation between the reading from the dynamic cone penetrometer to the value, the CBR value that you actually get. So I would recommend those that are going to utilize the DCP to make sure you read up on it and understand some of the geotechnical implications of using it. But as a pavement designer for many years, I'm comfortable with the results that I get from the dynamic cone penetrometer and would recommend using it for those that understand and have used it in the past. Next question, for amateur designers, how would you suggest we determine what 28-day flex or compressive strength to use? That's a great question. There's a lot of good information out there that you can get. Typically, the way I specify is when you're doing street design, roadway design in a fairly benign environmental condition, not a whole lot of freezing and thawing and things like that, then you can use those lower flexural and compressive strengths. 3,500, something like that is certainly appropriate. When you get into higher traffic levels where durability is an issue, where environments where you have situations where you have a lot of freezing and thawing and that type of thing, then the higher flexural and compressive strengths would be necessary, and getting up to that 4,500 and maybe even slightly higher would be appropriate. Where to go for that? There's a lot of good information out there. NRMCA has some. ACPA has good information on material selection. So there's information. And again, if you're one of those that just is uncomfortable about making those types of decisions, go to our paveahead.website and go to the Design Center tab and get information from us directly. If you fill out that contact information, then we'll send you or we'll call you and ask you about your particular project and how we can help you design that project. Next question, would limiting joint spacing help with water intrusion for softening subgrade? Okay, so I think what the question is related to is if we keep our joint spacing a little bit closer, then what happens is the joints stay really, really tight. They don't tend to open up when you have changes in temperature, thermal contraction and expansion with temperature. So yeah, so there's a couple of things I would say there. One, yes, you could decrease your joint spacing a little bit to make sure that those joints stay very tight. The only thing I would say there is by decreasing the joint spacing, you're obviously increasing the number of joints and the linear feet of joints in a pavement. So you're also increasing the ability for distress at the joint, spalls and things like that. So it's kind of a balance, but it's a good observation that if you really are concerned with water intrusion, you can do that. Other things you can do is just simply make sure that you have good water flow, good sheet flow off of your street or your parking lot, and you're designing in the appropriate crown for that. Next question, what about the border condition or load transfer? So I think what they're talking about there is what the edge condition is and how you're getting appropriate load transfer either longitudinally across that longitudinal joint or maybe at the corner there at a transverse and longitudinal joint. There's a couple of things there. One, your border condition, you want to make sure that if you have a shoulder or a curb and gutter that you tie that to the actual pavement itself. That helps with reducing the edge stress, so that's important. And then also, when we get to the point where we think we have enough vehicles and enough heavy vehicles, or heavy axles, then we might recommend using dowels across our transverse joints so that we get good load transfer from one slab to the next. When we don't have dowels there, we're utilizing aggregate interlock across that joint to make sure that we get load transfer from one slab to the next. Once we start getting above 100 to 200 heavy vehicles per day, and we have thicknesses that are in excess of about 7 or 8 inches, then we might want to consider dowels at our transverse joints. Another good observation, our designers switching from designing for 20 years to 40 years, most certainly. Our designs that we do these days are anticipated to last for a very long time. It is a balance, again, between economy and proper design. But it's not unusual to see states and even cities and counties now require doing longer life initial designs. When we talk about doing a 20-year design, what we're talking about is a design where we do very, very little maintenance and rehabilitation throughout that initial 20 years. It doesn't mean that there won't be some, but there will be times in which we have to do some maintenance and rehab within that 20 years, but we can design it to be thicker or to include other design details like treated sub-bases and things like that to extend that that initial life out to 30, 40, even 50 years. But that comes at an increase in initial costs. So again, there is a balance to that, but it's a very good observation that we're kind of moving away from that 15, 20-year initial design to something that's more or higher. It's higher. Next question is, so no more easels or equivalent single axle loads. Can easels be entered if an agency currently uses this for design? That's a good question. Most concrete design, when we're utilizing the PCA methodology, has used the axle load spectra for a number of years. But if you're one of those that's more comfortable with easels and speaks easels, I showed in the streets section where you can kind of back calculate what your number of trucks per day are based upon your asphalt cross section. But we do not at this time have an easel conversion in pavementdesigner.org. You can go to a couple of different websites where you can download an easel converter. I'm sure many of you that have done easels in the past or have done concrete design in the past have developed your own little spreadsheet of converting easels into number of trucks per day. All right, just a couple more questions and then we'll end. We're about 1 minute over. Is there a way to accommodate effects of variation in temperature and moisture in design? These effects will directly affect material stiffness. A great observation. The only way that you can do that is by changing your subgrade soil characterization value. What I tend to use is a little bit conservative, but I tend to use a saturated condition when I design. And as long as I feel like it's not overly affecting the thickness, then that's typically what I will use. Currently, we do not have a way in which we can put in a different soil strength value for the different season, but that's certainly something that we could add in the future to the website. Is there any consideration for reinforcing steel in this design program? Certainly you saw that in the continuously reinforced. So you can design a CRCP pavement. We do not do steel design for just jointed concrete pavements. If you go to the ACI 325 guide or the ACI 330 guide, it does talk about inclusion of steel in certain instances, maybe when you have expansive subgrades or when you have irregular shaped panels and things of that nature. So it does address the use of steel, but we do not utilize steel as a design criteria in the pavementdesigner.org. It's really not needed if you control your joint spacing to 15 feet or less. A maximum of 15 feet, but when we get into thinner pavements that 5.5, 5, 4.5, then closer joint spacing, then steel is really not needed in our pavements. And the last question, what basis is used on selection of the max joint spacing of 9 foot for a 5.75 inch thick pavement used in the second example? It's a great question. We went back to looking at a combination of the subgrade stiffness and the concrete material property types to determine those joint spacings. Now, we recognize that those joint spacings are a little bit conservative, meaning they're a little bit closer than what you would normally see in terms of joint space recommendations. But again, what we put in there is what we would consider an appropriate joint spacing. We know that there's other information out there that kind of contradicts that, particularly in the ACI 330 and the 325 guide. But we just put that in there because we wanted to account for both the subgrade stiffness as well as the concrete material properties. I'm going to conclude the webinar at this point. We're about 4 or 5 minutes over. The one thing I will say, I'll go back and show the screen that has the website, or I'm sorry, the email address. Let me get that real quick for you. So again, if you want a PDH certificate, just simply go to or send the request to me at bkillingsworth@nrmca.org. That's bkillingsworth@nrmca.org if you want your PDH certificate. I appreciate the time that y'all dedicated to the webinar today. And again, if you have any questions, contact me via my email. You can call me. Or if you go to the PaveAhead website under the Meet the Experts page, my contact information is there as well. Y'all have a great, wonderful, or have a wonderful rest of your day.